Okay, so these next few problems all involve modifying the walking turtle problem that the workbook here has defined earlier in the chapter. So let's go back and get it. I should have done that before I started doing the video, but whatever. Whoops, that is the index and not the table of contents. There we go. So it was back in here. So this is the first version. This is the second version. Just run it to make sure this is right. Okay, that looks good. So they just want us to take all of this. I wish that this was just between me and you. One, none of these functions that they've defined have doc strings. That's annoying. And two, there's not a single comment in this entire block of code here. So I wish they would have done that for us. Unfortunately, all the actual documentation for it is outside in this description. So, keep this page open so you can remember how to actually utilize this program that they've written. But I am not going to keep it open. I'm just going to head straight back into the exercises. So scroll down and exercises. Awesome. Okay, so I've got that. I'm just going to paste it right in here. Okay, so just as a quick rundown of what we got, remember that this program that they wrote made it so where it's going to create a turtle, and it's going to make that turtle turn either 90 degrees left or right, and then take steps until it leaves the screen. So let's go through and break down what this program's actually doing currently. So it's importing random and turtle because they're using random to choose, I guess, whether or not it's turning right or left. And they're importing turtle because obviously that's what we're using. I'm going to add in a doc string to this. Don't feel like you have to, but returns a boolean if turtle t is within the bounds of screen. I'm going to actually of window screen. That's maybe less clear than it could be, but that's what it's going to do. I'm also going to make a couple comments here. This is determine the border of the screen is what this section up here is doing. This section right here is retrieve turtle's coordinates is what this is doing. It's getting where the turtle is on the screen using the built-in methods for the turtle object and storing them in these variables over here. Then it is setting up initializing. They're initializing here a boolean still in to true. So it's making it so where it's setting still in to true so that if it can check to see whether or not it is still in and then just return it otherwise. So it's setting it up essentially so that it doesn't have to do more complicated logic down below here. So it's setting it's creating a variable still in that is equal to true, and then it's testing down below. Test if turtle has left the sides or top of the screen. If so, set still in to false, and then return still in at the bottom. So that's what this function's doing. It's going to return a boolean if the turtle is within the screen. So when we pass in a screen and a turtle, it's going to look at the screen, see how big the screen is, see where the turtle is on the screen, and then see whether or not it is outside the left or the right, or the top or the bottom, and then if it is outside of those things, it's going to return false. If it isn't, it's going to return true. And then here is our main function, where is just Julia is our turtle, screen is our screen, and then Julia is getting set to the shape of a turtle. And then I'm going to actually bump this down for readability. So we're using a while loop here. While Julia is still in the screen is what this is saying. While is in screen, Julia returns true. It's setting up a coin and flipping the coin. It's either going to be 0 or 1. If it's 0, she's going to turn to the left. If it's 1, she's going to turn to the right. And then she's going to walk forward. Okay. So again, all we did was document this function. So it still just runs the basic way. But now we've got it in place so that we can use it in the future, and it's hopefully a little bit more readable. So we'll wait till Julia walks off the screen here, and we could be here a while. Come on, Julia. There we go. Okay. So what we need to do now is change it so where instead of doing a perfect 90-degree churn, she churns randomly. So we can do that really easily. We already have a rand range function in here. They're already using the random module, which means all we need to do is instead of having her churn left or right randomly, we can have her churn left or right somewhere in the range of 0 and 91. I'm doing 0 and 91 because rand range is exclusive. So it excludes its top number. So it does somewhere between 0 and 90 is what this is saying. We could do, if we wanted to do it a different way, we could do rand int, which is inclusive, but I'll use rand range because that's what they've used here. And then I'll also do it down below, random rand range 0, 91. So what I've written here is I've written it so where if she gets a 0 on her coin flip, if she gets a tails, essentially, she turns left somewhere between 0 degrees and 91 degrees. Now I could change this to be 1 and 91 if I wanted it to still churn some amount, and I'm going to do that, though you don't feel like you have to. You know, obviously make this your program. Okay, so she's going to turn somewhere between 1 and 91 to the left, otherwise she's going to turn somewhere between 1 and 91 to the right. So she's still either making a left turn or a right turn, but it's going to be somewhere between 1 and 91. Now, this is maybe not great, right? Why? Well, it's still turning either left or right, so it's kind of like wandering all over the place here. Is there a better way that we can do this? Or a different way that we could do this? There is. So she's either turning left or right here. We can make it so where the turn angle, the turn is determined randomly, completely randomly. So we actually, sorry about the dog, we actually do not need this coin flip, right? We don't need this coin flip. We don't need this if statement, this else statement. All we need actually is just a random range function. Whoops. All we need is a random range function. Make sure I'm hitting the right buttons. And I'm going to set that to a variable called churn angle. And then I'm going to make that be equal to random rand range somewhere between 0, so not churning at all, and 361. So somewhere between 0 and 360, 361 exclusive. And then she's going to churn left by that churn angle. And then she's going to go forward. So while she's in the screen, she's going to pick an angle somewhere between 0 and 360 and churn that churn angle and then go forward. So let's see. So now she's truly random, even though it's going to now make it kind of a little bit weirder. Instead, really before, she could either churn left up to 90 degrees or right up to 90 degrees, so it's only getting us a churn radius of 180 degrees. Now she has a full churn radius of 360 degrees, and you see she's spinning left. We could throw it back in and make it so where sometimes she also spins right, but there's not really a reason to do that, because giving her that full range of 360 means that she's going to churn somewhere between 0 and 360. If we wanted to still give her left or right, we could still flip that coin. So I won't retype this out, but what we could do is we could flip a coin, and if heads, churn right between 0 and 180, if tails, churn left between 0 and 180. So if we wanted to do that, so where she still could churn left or right, even though a right churn of 360 is the same thing as a left churn of 0, so it doesn't really matter. If we wanted to make it look more like she was making a choice between left or right turns, we could do this. But as it is, what we have here is completely functional.